So we've talked a little bit about different types of data, but we want to learn about how we can get that data. I mean, how do you collect your data? Now, there's a couple different ways you can get data, depending on what you do. Let's start with a couple broad distinctions, and that is you could do an observational study in which you just observe things, but you don't actually intervene in any way with the subjects being studied. So it's kind of a hands-off approach, but observational study. Now, in contrast, in an experiment, you're actually modifying the conditions or applying some kind of a treatment to your test subjects. So two different approaches. I guess it depends on what kind of data you need, what you're looking for. Sometimes you can only observe things, sometimes you need to experiment. It's just going to depend. So let's take a look at a couple different examples here and decide what we think, whether they're observational studies or experiments. So, problem number 6 here says a clinical trial of the cholesterol drug Lipitor. 188 subjects were given a 20 milligram dose of the drug. 3.7% of them experienced nausea based on data from Pfizer. So, is this an observational study or an experiment? Gotta vote for experiment. Yeah. Well, if it was observational, you'd just be watching them hands off. But you're actually giving them Lipitor. So that's changing the conditions. So this would be an experiment. How about problem number 8? Happiness survey. In a study sponsored by Coca-Cola, 12,500 people were asked what contributes most to their happiness, and 77% of the respondents said that it was their family or partner. So again, observation or experiment. It's an observation. This is all hands off. You're not giving them a glass of Coke and saying, "Hey, drink this and tell me if you're happy." You're just asking them, what makes you happy. So you're not changing their conditions at all. So you're just making observations. It's tough to get good data. In fact, we'll talk a little bit about that as we go through the different types of sampling. Sampling is a way to collect data from a subset of a population, and there's a lot of different forms of sampling. Now, some of you, if you're watching me during the break, watch me poking around, etc., they literally have entire books on survey sampling, how to conduct good surveys. I mean, there's just so many things that affect your ability to get good data, including the order of the questions that you ask things. So it's really difficult because sometimes if you change up the order or you change the way in which you ask a question, it can change people's response. And a lot of times you get people who want to please the questioner or are afraid of making a response that is socially unacceptable, etc. It's particularly difficult if you're dealing with really sensitive issues like, do you take drugs? People aren't going to generally want to answer that in an affirmative to somebody who's just calling at random on the phone. So there's other ways you can get around that. But let's get back to the task at hand, which is to understand some of the different ways by which you can collect data. Let's see, do I have these? Yeah, still have them on our sheet. So one thing that you're going to see is there's two things that seem to be pretty close to each other. There's a random sample, and then there's a simple random sample. Random sample is a sample in which each member of the population has a known equal chance of being selected. A simple random sample is a little bit more particular. This is a sample in which every subset of size n has an equal chance of being chosen into your sample group. Now that distinction is not really going to be a big issue for us, but it is a little something that I will point out. A lot of times when people say random samples, they really mean simple random samples. All right, so let's go on to the different methods of sampling. There's systematic sample, so you can take every third element or every kth element in a list. There's convenience sample. In fact, the author has a nice graphic displaying a lot of the different types of samples in his book. So systematic sampling, you're just choosing every third or fifth or whatever one. Convenience sample, I like this. This is somebody yelling out the window and saying, "Hey, do you believe in the death penalty?" All right. Well, I don't think you're going to get a lot of good data from something like that. Stratified sampling. What you do in there is you divide your population into different groups, Democrats, Republicans, men and women, etc., and you make sure you sample enough within each group. This is something in particular you would apply if you want to make sure that you get lots of minority populations represented. You target getting people within that so that they get their voice represented as well. Cluster sampling, yet another way that you can collect data. You divide your population into different groups or sections, or clusters as they call, and then you randomly select those clusters, maybe at a voting precinct, etc., and sample everybody within that cluster. A lot of times these methods are applied with layers that you do cluster sampling within stratified sampling or vice versa, etc. So you can nest these together to try and get a really robust set of data. Let's spend a little time though looking at different problems that ask us to decide what kind of sampling was used. We'll start with problem number 24. Is that what I want? No. No, just no. Let's go back up to problem number 10. So the goal here is to decide what type of sampling method, random, systematic, convenience, stratified, or cluster, was used. The sexuality of women was discussed in Shearheight's book, Women and Love, A Cultural Revolution. Her conclusions were based on sample data that consisted of 4,500 male responses from 100,000 questionnaires that were sent to women. So the question for us is, what type of sample is this? Is it systematic? Is it convenience? Is it cluster? Is it random? So again, we got random, systematic, convenience, stratified, or cluster. Well, let's start eliminating things. Is it stratified in any way? No. No. Are there any clusters that were being sampled here? No. Okay. What else can we eliminate? Yeah, systematic. Not there. So it doesn't exactly seem to be random. You get these 100,000 women, and what's happening? They're all just choosing whether or not to send in their response, right? Does she get a good response rate? No, that's like 4.5%. Yeah. Yeah, 4.5%, right? It's not a really good response rate. I'm not sure how comfortable I'd be with conclusions based on data here. This is another one of those self-selected, right? You choose like, well, okay, I'll fill it out. And obviously not many of them filled out. That was the problem in our most recent presidential election. There was a lot of undecideds, and the response rate to questionnaires and surveys, etc., is getting smaller. I think back in the early 2000s, you would get 25%, maybe 30% of people who would respond to a survey request. Now that rate's dropped down to like 15%. So it's harder and harder for people to get data. And in the most recent election for president, I think a lot of those votes broke for President Trump. Okay. So this one then would be a convenience sampling. Just like, okay, we've got these 100,000 names, and we'll just take whatever data comes our way. Because they don't have a huge cluster of male and female, and then decided at random to sample all of just one. It was just this group of 100,000 women who were mailed the questionnaire, and they chose to be in or not. So let's move on to problem number 12. When collecting data from different sample locations in a lake, a researcher uses the line transect message by stretching a rope across the lake and samples at intervals of every 5 meters. Stratified, yeah. It's regularly 5 meters, every 5 meters. So stratified, good deal. Well, stratified or not? That's systematic. Every 5 meters. Acupuncture study. In a study of treatments for back pain, 641 subjects were randomly assigned to 4 different treatment groups of individualized acupuncture, standard acupuncture, simulated acupuncture, and usual care, based on data from randomized trial comparing acupuncture. So the question is, what kind of sample is this? Now this one's not quite as clear, I think, as the last one. But the word that, yeah. So they're assigned to these 4 different treatment groups. So it's an experiment. But these subjects were assigned randomly. And then you collect data from these subjects on their back pain. Well, let's go through all of them. Systematic? Well, not exactly. I mean, it's you don't have like a starting point, etc. The subject were randomly assigned here, so it's not like, all right, the first one goes here, the second one goes here, etc. So let's scratch off systematic. It's not a convenient sample. It certainly looks like it's a little bit more involved than that. Stratified. They're divided into different groups, but you're not sampling within each of those. Well, yeah, they're all getting placed into one group or another. You're not sampling within those strata. You're putting them into that strata. or you're putting them into those groups. So you're not sampling from within them. So I think I'd rule out stratified as well. Convenience, cluster. They're not clusters. You don't have a bunch of these and you're sampling everybody with this one particular treatment, so it's not cluster. So yeah, it's just a random sample. And I guess I'm getting at that by process of elimination. We're not actually going all the way it's just yeah, it's right. So it's a random sample. And like I said, I think I'm most comfortable getting at that conclusion by process of elimination. Let's do a couple more. Problem number 16. The author collected sample data by randomly selecting 20 pages from a printed version of Merriam-Webster's dictionary and then counting the number of words defined on those pages. Yes. Now, why cluster? Yeah. So your collection, your clusters are the pages. And you're sampling, you're figuring out how much data is available on each of those pages. So once you pick the page at random, you're sampling everything on that page. So that would be a cluster. Let's do one last one here. Problem number 20. New York State Department of Transportation evaluated the quality of New York State throughway by testing core samples collected at regular intervals of 1 mile. So if you're testing every 1 mile, that would be systematic. That'd be systematic. So there's a lot of different types of sampling methods. Like I've said a couple times today, one of the things to avoid is the convenience sample, stuff that's collected with a self-selection bias. I mean, if you ever see polls on the internet, CNN has a lot of polls, etc. But be wary of data that's just collected by people that visit a site. It's not representative of much at all other than who happens to visit the site. There's another problem with that as well, is that sometimes people are drawn to a site because they're motivated in one way or another. Maybe it's something that we could study this semester. I'd be kind of curious about it myself. But just a show of hands real quick. How many people look at Rate My Professor to figure out? Yeah. All right. Now, what I'd be curious to see is if there's a tendency for either really, really high votes or really, really low votes. My guess, and I've never studied it, is that a lot of times there's probably not too many people that get like a middle grade. My theory is that people that go out to Rate My Professor are motivated. They either really, really like somebody or they really, really don't. You're not going to get two people that are like, yeah, he's average. I'll just go out and rate my professor and give him a C. I think, and it'd be interesting to study it, that you tend to get 4s and 5s and 1s and 2s. But it's just a hunch. Let's finish up a couple more problems by deciding whether a sample is a simple random sample or not. And we'll do problem number 22 to start with. In order to test for a gender gap in the way men and women purchase cars, the Grant Survey Company polls exactly 750 men and 750 adult women randomly selected from adults in the United States. Is this a simple random sample? Well, the fact that you have the exact number of men or the same exact number of men and women, yeah, it seems like you're doing some stratified sampling. You have men and women, your two stratas, and you sample exactly the same number in each. So it might be a random sample within the strata, but the overall method itself doesn't strike me as being a simple random sample. Yeah, it'd be highly unlikely if you're doing a completely random sample to get exactly 750 women and exactly 750 men out of 1,500 people surveyed. So that one's not a random sample, not a simple random sample. According to the state of New York, Unified Court System, names of potential jurors are selected from a variety of different sources. When a trial requires a jury, names from the list are randomly selected in a way that is equivalent to writing names on slips of paper, mixing them in a bowl, and selecting the required number of potential jurors. So, sorry about that, I didn't have that focus there. What do you think? Is that going to be a simple random sample? If you're pulling names out of a hat, essentially? It's a random sample. Now, the distinction is for a simple random sample as opposed to a random sample, you have to be able to get all groups of size n. Let me flip back to the author's diagram right here and try and explain that a little bit more. If you're trying to get, say, a sample of size 3 out of this group, or let's do a sample of size 4. In a simple random sample, you have to be able to get every group of size 4, no matter where they are. Now, if you're doing a systematic random sample in which you take the third person every time, there's no way that you could get all 4 of these guys as part of your sample because they're not spaced apart that way. So this couldn't give you a simple random sample because this group would have no chance of being in there. Every group of size 4 has to have an equal chance of being in your sample. So you're not going to get that here. If you're drawing names out of a hat, though, that changes things. If you're drawing names out of a hat, do you think you could get any group at all? You know, pretty much, yeah. Your chances of getting any group of any specific size are going to be the same regardless of if it's the first 4 guys here or the 2 n guys, etc. Whatever group of size 4, and actually later on we'll learn to calculate that there's actually quite a few of them. Let me think. Stat, math. So there's really 495 different ways we could choose a group of size 4 out of that group of 12 guys. That's a lot. It's an awful lot. But in a simple random sample, all of those are equally likely. And that's going to be true here when we're doing the computer equivalent of choosing a name out of a hat. We'll have a simple random sample. So for problem 24, the answer is yes. This is a simple random sample. For homework in this section, try problems 1 through 25.